a bigger function at all points.
Because the denominator for this one is always
2 bigger.
2? Yeah, 2 bigger. Like a sum of 2 bigger. Yeah, I totally agree. So what I would say here then is 0 is less than 1 over 2 plus 3 to the n, which is less than or equal to 1 over 3 to the n. Does that relationship make sense? And the reason why this middle, which is the thing we're looking at, the reason why this middle term is smaller is for any given n value, wouldn't the denominator of that one be 2 bigger than 1 over 3n's denominator? And if the denominator is always a little bit bigger, then the value of the fraction is always a little bit smaller. Okay, so nice work, Aiden. I think that's a really good comparison. And I'm going to put on the interval, because the interval here potentially really matters, I'm going to say on the interval from 1 to infinity. So we're setting up our comparison. So I've established the vertical relationship. The one we're focusing on is less than our comparison. So I'm going to go ahead and then work on my comparison. So I'm going to say sigma from 1 to infinity of 1 over 3 to the n does what and why? Does that comparison that Aiden came up with, does it converge or diverge?
It converges because it's geometric.
Ah, there we go. So this converges. And the reasoning would be the geometric series test. We want to go a little bit deeper. What's the common ratio for this particular geometric series?
1/3.
That's right. So R equals 1/3. And then how is that 1/3, why is that important for our geometric series?
Because as it keeps getting multiplied with itself, it's just going to get smaller and smaller.
Right. And what are those key numbers?
R is between 0 and 1.
There we go. We want it to be between 0 and 1. Yeah. So we could say that 0 is less than 1/3, which is less than 1. We've written that in a little bit of a different way in the past with absolute values, but this would be fine.
Is it 1/3?
So the fact that the numerator is a 1, so you could rewrite this as 1/3 to the n,
yeah.
and it'd be the same series.
Yeah, but even if it was like 2 over 3, then we just
Factor the 2 out, and we're back to the thing we wanted. As long as it wasn't parentheses 2/3, because then it wouldn't be a 1 anymore, right? It would be something. We can still handle that, but
it was like 2 to the end.
right. I mean, it still would be handleable, but the thing you mentioned is fine. Yeah. Okay. So basically, at this point, what I've proven is that Aiden's comparison series converges, and since the series that we are looking at is always lower, then what's our conclusion? It has to converge too. So we can say, therefore, our original series we were trying to analyze in the first place also converges. And then the name of this reasoning would just be comparison, or you could call it direct comparison. Nick, what's up?
I know for our test you want us to list the reasoning, but for the
AP test?
no.
The only time when that would come into play is I think I can see like the harmonic, and later on we'll learn about the alternating harmonic, because those, all you have to do is name them, right? If you just say, that's a harmonic series, therefore it diverges. So in that case, I think naming it would be the optimum way, because you don't have to go through and do a whole integral test to prove yourself.
Yeah.
But in this case, if you just said everything but the whole comparison thing on the AP test,
Okay.
it's all good.
All right.
Yep. You bet. Okay, so I think number 2 is a bit tougher than number 3. So would you guys jump to 3, and we'll come back to 2. So go to 3, we'll come back to 2.
Number 2 is bad.
Please try number 3. Oh. I'm going to let you guys do that for a moment on your own. I got to do attendance real quick. It's a little bit tough. So we're looking at number 3. And so maybe you've done this already. I'm not going to give it away yet. Like the nth term test goes to 0, so that's meaningless for us, right? It's not geometric. Integrand, well, I don't think we're going to be finding an antiderivative of that anytime soon. So the integral test wouldn't work. It's not a p-series. Why is it not a p-series? Because it's close.
There's a plus one.
The plus one makes it not a p-series. It's also not harmonic because it's n cubed. It would have to be linear down there. So like all those other tests just don't fit. And so that's why maybe comparison would be, either one of these comparison tests really would be the best way to go. Did anybody think of a good comparison on this one? Okay, so let's try it out.
Test.
Say again?
When you can use the p-test.
You can, and that's always happy because it's not a very complicated test. Yeah. Okay, so you all suggested 1 over n cubed. So that means this is really similar to the other one if this is going to work, right? Because we could do this and then this, right? That relationship should hold because wouldn't the denominator of r's always be 1 bigger on our interval? So I would just say on the interval from 1 to infinity. And then Julia said we could use the p-test here. I think that works. So we'd say sigma from n equals 1 to infinity of 1 over n cubed. So using the p-test, does our comparison converge or diverge? Converges. Okay, now let's give a little bit of detail why. Because why?
P equals 3, so P
P-
is greater than 1.
P equals 3, which is bigger than 1. That's right. So you said that right, Aiden. If all you said was P equals 3, there's potential for confusion, right? Because it's like, is 3 the magic number? It's really 1 that's the magic number, so you want to relate it to 1. And then you can say, therefore, our original series converges also, and that is by comparison. Okay, you guys good? So look at number 2. So please check out number 2. And I think you'll find a similar line of reasoning with number 2 in that all the other tests we've looked at so far don't seem to fit very well with number 2. So check that one out.
Go back to what, number 2?
Yeah, go back to number 2, please.
That's what I,
Oh, that's that one. I thought I was smart.
But if you do the p-test of either one half, then it diverges. So then you get to choose the function.
I will say that there actually is one really simple series that works here.
If you choose a higher.
Might not be simple to figure it out to get to it, but there is one that we found in the past that is quite simple to work with.
A diverges and B diverges, but if B diverges,
She's a smaller one.
yeah,
Like
she's small.
3.
But like, we don't have a test for that.
but we do.
What if you chose like n over 1 cubed?
Can you bring it up?
1 over n to the 1/3.
You can also just do 1 over n, because you know that 1 over n
You can split them.
is below it,
How is 1 over n below it?
because the exponent is bigger. Because it's one over, hold on, it's 1 over 2 to the 1 over 2 plus n.
Oh, you're right.
Yeah,
Just
you
do
are
1
right.
over n.
Yeah.
I love you, Jack.
Does it work? Have you tested it out?
Nope.
Should work.
Yeah.
So we gotta be super duper careful with that though. So I'm gonna write something false up here. So if I wrote this would actually be, this would be bad. So I'll show you a couple of bad things. So if I wrote 0 is less than 1 over 2 plus root n, which is less than or equal to 1 over n. If I just stop right there, this is false. This is not always true. And the way that I've written it up there, I'm
On the
saying,
interval,
so,
no, 1 over n is less than 1 over 2 plus.
oh, so you want to go that? I thought you were saying this way.
Right, but it goes 0.
So you want the 1 over n in here?
Yes.
Okay. I thought you said it this way. Okay. So, if I write it this way, listen up, please. If I write it this way, this is also false or not always true. Logan had the idea of, hey, we better include the interval. So, if I write this,
Yes, I love that interval.
if I wrote this,
Oh, that's not true.
it's also sort of false too, isn't it?
Well, yeah, why would
At what place is this true? Because right now it's not true.
From
But you don't have to, you can't include one, right?
So if I put 1 in there, then I get 1 over 1 and I get 1 over 3, and 1 is not smaller than 1/3, right?
Oh, you could do 2 plus n.
No,
could
can
do
you just
n-
make it
You could do
curve?
n plus 2.
Let's just adjust the interval. Let's not mess with the lower n value, because I don't have a sigma in there.
Oh, so you can just do from like.
Where is it? So if I try a 3, it'd be 1/3 is less than 1 over 2 plus root 3.
Which is still.
Yeah, it's still false, because root 3 is about
4 would be the
Four.
same.
4, they're the same. 4, they're the same, right? So it'd be 1/4 and 1 over 2 plus root 4, which is 1/4. So if I were to take this, and instead of 1 to infinity, if I just wrote it as 4 to infinity, let's talk about why that's important. Number one, it's true now, right? But aren't we only really concerned about the right-hand tail of this thing? Like what's happening way out there? I mean, whatever's happening with the 1, the 2, and the 3, that would affect the sum ultimately, but would it affect the convergence or divergence? No. It's just a finite number added onto either convergence or divergence. It's just not going to matter. So now this is true. And so now I think we potentially have a good comparison. Okay. So I'm going to say sigma from 1 to infinity of 1 over n. Say again?
Do I just say 4 to infinity, or does it matter?
Yeah, just sort of n equals 4.
Well, I can make it, so I'm just about to make a general statement about this series. And whether I start at 1 or 4, it's not going to matter, right? So what happens to this series?
Diverse.
Why?
0 is less than t.
So he used a p-test. What else could you do? So this,
You could also do
the
an
integral.
yep, you could do the integral test. You could do the p-test. What's the other thing you could do?
harmonic.
Just identify it as harmonic. That's what I would do. I would say this diverges because it's
What is harmonic?
That's the one that really concerns
Because
me.
a equals 1 and b equals 0.
harmonic is always of this form right here. Sigma of 1 over a n plus b, and in this case is 1b0.
Has there been an AP test where they've given a harmonic that's not just 1 over n?
Well, yeah.
Not often, if ever. Most of the time it's just 1 over n.
Oh,
Wow.
that's nice.
But if it's 1 over 5n plus 2, you could just use the integral test if you didn't identify that as a harmonic series. Okay, so then 1 over n is lower than the series we're concerned about, and 1 over n diverges, so that means anything above it also diverges. So I can say, therefore, my original series also diverges, and the reasoning there, of course, is comparison, or direct comparison.
So that one, you just have to be super careful about that bound.
Saying all true things. Just say true stuff. Yep. But your identification of 1 over n and thinking about, okay, n versus root n, eventually it's going to cross under, makes sense. Definitely makes sense. Okay, let me give you a brief preview of our other comparison here. So check this out. This is one of my all-time favorites because this is super powerful, and this allows you, like in a multiple choice scenario where you don't have to really show any, guys listen please, in a multiple choice scenario where you don't have to show a lot of extra work, this limit comparison test will make you really, really fast, which is great, right? So the limit comparison test, we are going to be comparing, this is going to sound so silly, but we're comparing two limits, and we'll use a limit to compare them. Honestly, that's why it's called the limit comparison test. We're going to compare them with a fraction, like compare them in fraction form, and then we're going to do a limit of that. So I'll tell you what. No, I'll just save that one. I'll just save that for later. I was going to just show you one really quick, but I don't think that'd be very, very beneficial. So we'll just do those. We'll just do those next time we see you. But on Monday is when your parametric vector polar test is, right? So I just want to remind you of that. Whoops. The good news is parametric vector and polar, they're all parametric. And so you could just think of this as like the all-encompassing parametric test. And hopefully our good little discussion here was helpful on some fronts. But please do go back and do a little study and a little reviewing. This will be your first test score of the semester. So if you have an 84 right now, you're like, man, I really wish I had a 90-something. You could make that happen here.
You've been looking at my grade.
And it could go the other way too, right? So please.
Man, I really want to see in this class.
So let me see if I can take my 91 and drop it to a 74. No,
Oh, you really looked at me
Less.
right in this, because I do have a 91 in this class.
Oh, you do? Sorry.
Nice one.
There was no intention there.
Whatever, Logan.
Now you have to get a
Stop.
74.
No, he needs to get like a 94 or something like that, right?
Pop it off right
All right. Hope you guys have a great weekend.
You know what?
See
I
you
haven't
later.
done it all year yet. So I'm going to take one for myself.